Enrico Pirotta. I'm a research fellow at the Center for Research into Ecological and Environmental Modelling at the University of St. Andrews. I'm a quantitative marine ecologist, and most of my work focuses on developing and applying approaches to study marine mammals, particularly the way they relate to their environment and interact with human activities. And so most of the projects I'm involved in try to assess the effects of stressors from human activities on marine mammal individuals and on populations. So in this project, we were trying to tackle this complex problem of trying to understand the effect of multiple stressors on the survival and reproduction of North Atlantic right whales. This is a critically endangered species that is exposed to many stressors, including entanglement in fishing gear, vessel strikes, and climate change that affect their prey. And so trying to assess these effects and compare them is really important if we want to devise measures to protect them, essentially. We had access to a large data set spanning 50 years of right whale sightings, health data, life history data, and exposure to stressors. And we developed a Bayesian model to model the health, survival, and reproduction of individual whales, which allowed us to compare their effect sizes in the context of other aspects in the life history of an individual that could challenge an individual, for example, lactation or being a juvenile. Yeah, it was quite challenging to develop this model. It's a very data-hungry model, so we had to use a lot of data. But even though we had this 50-year long data set, it's still quite hard to estimate all these variables within the same modeling framework. So from a statistical perspective, it was quite challenging to come up with a modeling framework that was complex enough to capture the complexity of the system, but also simple enough that could be informed by the data that we had available. And it's particularly challenging to inform the health of individuals. And so we had these visual health assessment data that are qualitative measures of the health of an individual. And it's really not straightforward to try and link this qualitative data to an underlying quantitative health metric. But in the end, we were able to do it. Using this modeling approach, we found that entanglement in fishing gear and vessel strikes had the strongest immediate effect on individual health. And the effect of prey, even though it was smaller, it was protracted over time and it applied across individuals. And so as a result, we were finding these striking similarities in the temporal trend in individual health that we estimated and the temporal trend of the prey index that we used. This work is going to be relevant for policymakers and managers that are trying to come up with solutions to protect this species and ensure its viability in the future. And also for people in the ground that are collecting data from right whales. It provides some guidance on the pieces of information that are most relevant to assess impacts. And finally, because we developed this new modeling approach, I'm hoping that it will be relevant to other systems where researchers are trying to detect these effects. This project is a large collaboration between institutions in the UK and the US. There are researchers at the University of St. Andrews that are involved in terms of project management and also statistical development. We had colleagues at Duke University that were also involved in the statistical development. And then we were lucky enough to collaborate with some of the champions of right whale conservations at the New England Aquarium, Woods Hole Oceanographic Institute, and the University of South Carolina.